Okay, section 16.2. Now we've done integration. We've started the applications of that, and now we're going to use this to talk about volume and revolving a curve around an axis. And it's a little bit odd, but we're going to help you I'm going to help you get your head around it. If you take an area and you rotate it around an axis, you get essentially a solid. So if you think about, here's this curve, f of x. We don't know what that is, but it could be some polynomial function, something, but it's f of x equals something. And we're saying from A to B, we want to revolve that around the x-axis. So if I took that piece and I revolved it around the x-axis, I would get some solid of revolution. And if you think about it, when you're revolving, this distance here is the radius, okay, from the x-axis up to the curve. Well, what is the value right there? The value is f of x. So we're going to assume that the radius is f of x, okay? Now, if we did a little slice of this and we had this circle, how do you find the area of a circle? What's the formula for area of a circle? Pi r squared. So, okay. And we just said that the radius in this thing was f of x. So we could say pi times f of x squared. Would that give us the area of that one little circle? Yeah. Okay. So then if we took a lot of different circles, sliced this up into many, many, many different circles, and the more circles we could get, the closer we'd get to this big area. All right. Here is the formula that you're going to use when you are figuring volume of revolution, of a solid of revolution. Why is the pi on the outside? It's a number, so we can pull it through that integral sign. And it's pi times the integral from a to b. So from, my little thingy's not on. Let me get that on. Okay, from a to b. So that's like from there to there, a to b, f of x squared. And you want to be sure that whatever your function is, it's in parentheses, and then you square it. Then you take the integral of it, evaluate it from a to b, and you get the volume. What's happening is you're taking the limit of this. You're getting a sum. It's actually called a Riemann sum. If you've had calculus before, that might ring a bell. We're not going to go that deep into it, but this is the formal definition or way to do that. We're just going to be working with this right now. So we're going to have to know this one in this section, and then we also have to know the average value of a function on an interval. And so you're given some interval a comma b, and then if you take 1 over b minus a times the integral from a to b of f of x, you're going to get the average value of a function. So you have a few problems where you have to figure that. So those are the two things you're going to be working with in this section. Okay. All right. I want to show you some things here. Okay. And this is, if you go and you print the notes, you have them, Felicia. Is all this stuff in there, some extra stuff, or is it just the problems? You have those? Okay. So I think, if nothing else, if you go look at them, you wouldn't have to print all this, but you could look at these. You do have? Okay. All right. So this talks about, I wanted to show you. Okay. Have you seen these fold-out things like bells that you would decorate with, or Halloween pumpkins, something where they're flat, and then you pull them open and you clip them, and they become a solid thing. Well, that's kind of the idea here. We've got this curve like this, and if you rotate it, in other words, open it, you make a solid bell. Does that kind of help a little bit with the idea? And here's an R, and they've taken, if you took this R, this area, and you rotated it, they've got a cucumber, they've got a squash, you get some things like that. Depending on what the curve is, you get this shape, okay? And what they do, remember we talked about, they're taking this little area here, and they're rotating it so they have this cylinder, this little cylinder, okay? And we used to practice this in AP Calc. We did a lab with a lime and figuring out volume and all of that. It was quite fun. Anyway, wanted to just go through this, and you can see here's the curve, and if you did it, you would get this solid, and you would get that. Let's see if we go. I think this will work. Okay, this is also on there if you're on the computer and looking. And this is f of x equals x squared. All right, so I wanted to see if we can see the animation. There's x squared from A to B, because here's this parabola. And then it's making these little cylinders and finding the volume of each, the area of each circle, and the volume, and you get this solid. You can try that with all the different, no, I don't want to close that. I want to close that one. Oh, I didn't want to do that either. Okay, there we go. Anyway, you could go through and look at this gallery and look at the different functions and see how they rotate. That might give you a better sense of what we're doing. Okay? All right, so let's look at problems. Okay. You probably will want your calculator to help you do a sketch of some of these. Find the volume of the solid generated by revolving the region bounded by. So here you've got y equals 4x, x equals 0, and x equals 3. So these are the things that you need to know. The volume is so many cubic inches. So this is just a linear function. But when we graph it, you've got y equals 4x, but from 0 to 3, you're going to get this region that you're going to rotate. So go ahead and put that in your y equals, and let's see if you get a picture. And you're not going to get the region showing up on your sketch, but what you're going to do is have something to draw on your paper. You're going to have this line, and you're going to draw it on your paper, and you say, well, that's from 0 to 3, so I have this line here as a boundary, and I'm rotating this yellow part around the x-axis. So you'll use your calculator to sketch, draw in this line, because you can't get that on the calculator, and that gives you an idea of what you're doing. If you were doing the work for a test, that's what you would be expected to show, that you have this sketch and what you're doing. Then you could write your formula. So we have the volume is equal to pi times the integral from 0 to 3 of, what is f of x? It's 4x, 4x in parentheses squared dx. So once you've written that, you know how to integrate. You just need to square that and then integrate. So you would have pi times the integral from 0 to 3 of 16x squared. What could we do with the 16? Pull it through. So we have 16 pi times, then when you integrate x squared, it's x cubed over 3, evaluated from 0 to 3. What does that mean when we have this evaluated from 0 to 3? We're going to plug it in. And this 16 pi is going to get multiplied at the end. So I plugged in 3. 3 cubed is 27 over 3. You plug in 0, you get 0. And 27 over 3 is 9. And then 9 times 16 is 144. And so your volume is 144 pi. That one's pretty simple as far as integrating. If you had a complex one, what you could do is get it to where if you're pulling out a number, you could pull out the number. So you've got this pulled out. Then you could do math 9 and use the x squared, comma x, comma 0, comma 3, get some number, multiply it by 16 pi, and that could be your answer. So if you have a complex one, that's what you may want to do. Any questions on what we did there? Let's look at number 2. Find the volume of the solid of revolution generated by revolving around the x, and here's our stuff. We've got y equals the square root of x from x is 0 to x equals 18. So again, you're going to go to your calculator, you're going to put y equals the square root of x, get a sketch, and you need to make your window where it's going to fit. So your x max needs to be at about 20 so that you can kind of see what that region looks like. Square root of x from 0 to 18. Let's see what we get. Did we get a sketch like that? Okay, so I would expect to see that on a test, on the work for a test. I would expect to see that and have this line here so that you are showing me this is the region we're talking about. And then our formula would be v equals pi times the integral from 0 to 18 of square root of x squared. When you square the square root of x, what do you get? Well, it is x to the 1/2, but if you square x to the 1/2, what do you get? X. You just get plain old x. So you end up having that. That one's very easy to integrate. It's x squared over 2. And you're evaluating at 18 and 0. So you get 324 over 2, which is 162 pi. And it should have cubic units written out there. I don't, but you should. We'll add that. All right. Make sense? We're good? Okay. Let's look at the next one because it's a little bit different when you do your sketch. Okay. 2x squared, y equals 0, x equals 3, x equals 4. Where is y equals 0? The x-axis. So you're going to have this curve, you're going to have the x-axis, and you've got this interval. So throw that in the calculator, 2x squared, and kind of get a sense of what that's going to look like. That's what we're talking about. It's a small region from 3 to 4. Here's your 2x squared. Here's 3, here's 4, here's the x-axis. So it's this region bounded by all those things. Okay. And again, you want to be able to throw this picture down on your work to show what you did. And from there, it's pretty simple. If you have the work for this already, I would say maybe turn it over and try to go ahead and do this integration and do it by hand and come up with the answer. You're talking about pi, integral from 3 to 4 of 2x squared squared. Be sure that you put the function in parentheses before you square it so that you get the right thing. And you'll want it in fraction form. So let's see if we can get that. So when you do that, you would just be sure that you get this 4x to the 4th before you start integrating, and then pull the 4 through and integrate. You get x to the 5th over 5, evaluate it at 4 and 3, and your final answer should be that. Were we able to get that? Your inclination's to want to use the calculator, but this is what you're going to need for Math Lab. And it's really not that bad.
It is okay to take out the 1/5 from whatever you did.
Yes, yes, you could. Way up here, Kelsey, is that what you're saying? Okay, so you could have where is it? It's really one step above. Is that right? Oh, it's after you, well, hold on. Oh, it was after you integrated. And you just pulled the 1/5 and put it over here and did those numbers there. Yeah, absolutely. Absolutely. Go down. Is that good? Did you get that? Okay. All right. So these are going okay. Let's look at number 4. All right. Number 4 actually gives you a sketch. You could put it in, but they already have it for you. The function defined by y equals the square root of r squared minus x squared is a semicircle, and it has a radius of r, blah, blah, blah. Find the volume that results when the semicircle y equals. So here's your function. Y equals the square root of 25 minus x squared is rotated about the axis. What is r in this circle, semicircle here? What's r? Well, r squared is 25, so what's r? 5. And negative 5. So these points over here, that's going to be negative 5 and 5. That's going to be your interval. So you have to kind of realize that when you get ready to do that. So square root of 25 minus x squared, if you want to just draw that, let me scroll down to where we have that. Okay, so that's what we're doing. We're saying from x equals negative 5 to x equals 5, we've got this semicircle, and we are going to rotate it, and so let's get the volume. And when you set up your integral, it's pi times the integral from negative 5 to 5 of square root of 25 minus x squared, all squared. And remember that when you square a radical, you just get what's inside. So it's going to be the integral of 25 minus x squared. which is, again, pretty easy to integrate. You're going to have 25x minus x cubed over 3, evaluating negative 5 to 5. Do this for me. Try this on Math 9, doing this as your function. So you would do Math 9, and you would do 25 minus x squared, comma x, comma negative 5, comma 5. And we're going to see what we get, because this is a lot of calculation. Our goal is to get 500 over 3. Let's see if you get a decimal that turns into that. Can you? Okay, and then you would just add pi to it. So if you were allowed to use that method, that's how you would get it. If you had to do all this calculation, that's quite a few little steps. And that's really just working with fractions. I mean, that's arithmetic. So I wanted you to make sure that you could get the 500 over 3 pi. MathLab, it does want you to write it this way, so you might make note of that. They don't have 500 over 3 by itself. It's 500 pi over 3, one fraction. So, and I don't have a problem with you doing that one with Math 9, just remembering that you have to add the pi at the end of what you do. Okay? All right, the last two are using the average value function, and we don't have to have a sketch of that. Let's look back up here to 5. All right, here's the problem. Find the average value of the function on the given interval. The interval is here in brackets. It says 0 to 2, and you want to remember that's A and that's B in that order. Here's the function, x squared minus 2. And if we go back to writing that formula on your first page of notes, it's 1 over b minus a, integral from a to b of the function. So we're just going to do that. I'm going to scroll down to where the work is, but this is how we'll do it. So all it means is you're going to have 1/2 on the outside when you get ready to integrate. And you could go ahead and start working on that one. See if you can actually get that done. And it will want the value in a fraction, so I would say go ahead and just do that work and multiply the 1/2 at the end of your calculations. Just be sure and keep that 1/2 on the outside till you're down to where you just have one thing to multiply it by. And you should get negative 2 over 3. That one's not bad to have to do by hand. I would expect if you have one like that, you would show that work. The next one, I'm going to let you do it with Math 9. Yes, ma'am. Mm-hmm. That far or more? Okay. Anybody have difficulty with that? We're okay? Okay. The last one says, here's your function. They want to know the average value, square root of x plus 1 from 0 to 3. Let's do this one with Math 9, not having to do the calculations. But what are we going to have on the outside? 1/3? Yep. Because it's 1 over 3 minus 0 from 0 to 3 of x plus 1 to the 1/2. If you're doing it, if you're doing Math 9, you don't even have to do this x plus 1 to the 1/2. You can do square root of x plus 1 on the calculator. That's fine. It's just if you're doing it by hand, you would want to do this 1/2. But let's try it with Math 9 and make sure what we get, and at whatever we get at the end, we've got to multiply it by 1/3 or divide by 3. Where do we plug in what? You're not going to do that till the very end. You're going to do the Math 9, and then at the very end, divide your answer by 3. Does that make sense? And you would put it in just like this if you want to for the Math 9. This is if you were doing it by hand, and so that's on the notes if you wanted to see it, but I would say you could do this one this way. Let's see. What did we get? Let's see if you got... Did you get something that changed into that? Okay, so all the work for doing it, because you needed a U substitution, that was a little bit more involved, but you could do it with Math 9 fairly easily. Okay. Anybody not get 14/9 or have trouble with that? Do what? 14 over 3. Did you forget to multiply by the 1/3 that was the outside? Okay. Did you get it now? Okay. All right, so any questions? This is real quick on volume of revolution and average value function. So we don't get to go too deeply into it, but at least we know we've seen it. Okay? All right. Let me